Number 4 says, use the nutritional information provided for 2 different kinds of canned peaches to compare the sugar and content. Support your comparisons with unit rate. So it says we have 4 ounces here of peaches in syrup, and peaches in natural juice we have 6 ounces. If I have 21 grams of sugar in 4 ounces and 20 grams of sugar in 6 ounces, I'm going to put 21 divided by 4, because there's 21 out of 4 ounces, and then there is 20 divided by 6 for my next one. So this will get me an answer of 5 1/4, and this will get me 3.3 repeating. So I know that this is going to be the larger fraction, so this is going to have more sugar, because 21 grams of sugar in only 4 ounces is going to be higher than 20 grams of sugar in 6 ounces, okay? So I'm going to have peaches in syrup, okay? And then the next one says, which serving of peaches has a higher concentration of sodium? Use unit rates to explain and justify your answer. So again, now we're looking at the sodium. If we have 5 milligrams out of 4, I can write it 5 out of 4. And then if I have 15 milligrams of sodium out of 6 ounces, I can write 15 divided by 6. Now again, if you type this into your calculator, 5 divided by 4 is 1 1/4, and 15 divided by 6 is 2 1/2. So that means that 15 divided by 6 is going to be higher, so we have a higher sodium for peaches in natural juice. Okay, so we do have to take into consideration here how many ounces they're talking about. So if 4 ounces is going to be less liquid than 6 ounces, so that will make a difference when solving these problems. Number 5 says, if we have $12 to spend on lunch, we want to buy a sandwich and a few sides. The sandwich is going to cost us $6, and each side is going to cost us $1.75. A says, define a variable and write an inequality to represent the situation. So if I have $12 and I want to buy a sandwich, that means I subtract that. 12 minus 6 is $6. So we have $6 left over to buy our sides. Okay, so we're going to figure out how many sides we can buy with that leftover $6. So define a variable. So I'm going to make S be my number of sides. S equals sides. Okay, so that is how we define a variable. We are just writing the letter that we're using and what that stands for. So then our inequality, I'm going to take my number of sides times by $1.75. And remember, you can put a multiplication sign in here if you would like to. If I have it right next to each other, it also means multiplication as well. So I have the number of sides that I can buy times $1.75. I'm timesing it by $1.75 because it says each side dish is $1.75. So every time I buy a side dish, it's going to cost me $1.75. So that's why I'm multiplying the number of sides by $1.75. Okay, so if I buy 2 sides, I gotta pay $1.75 twice. If I buy 3 sides, I gotta pay $1.75 3 times. Okay, so that has to be less than or equal to my $6 because I only have $6 left to spend on sides after I buy my sandwich, because I only came to the restaurant with $12 in the first place. So here's our inequality right here. So what we have to do is solve the inequality, okay? This isn't finished. So to solve the inequality, we have to get S by itself. So I need to divide by $1.75 because I want to cancel this side out and get S by itself, okay? So S is going to be less than or equal to $3 or 3.42, okay? This is the amount of sides, I should say. So I can't get 0.42 of a side, so I'm going to say that I can buy 3 or fewer sides, okay? So I can buy 0, 1, 2, or 3 sides, right? I'm allowed to go into a restaurant and buy 0 sides and walk away with my $6. That's fine. But if I want to spend all $6, I can buy 3 sides with that $6, right? Because I have $6 left to spend, right? After I buy my sandwich, and we know that each side costs $1.75. Okay, so I got the number 3 because I solved my inequality and got, when I divided, I guess I should write on this side, I also divided 6 by 1.75. When I divide on one side, I have to divide on the other side. So 6 divided by 1.75 equals my 3.42. Okay, so that's how I know that I can get up to 3 sides. Now, I'm going to draw a number line at the bottom. I have 0, 1, 2, 3, 4, 5. So if we were to graph the number of sides that I can buy, I would graph it this way. I could buy 0, or I guess if you just got nothing, I could buy 1, 2, or 3. Okay, so this would not be a situation where we would draw our line to graph our inequality, because I can't buy 1.5 sides. I've never gone to a restaurant and bought a half of a side or a fourth of a side before. So that's the situation why we would only have our dots colored in like this. Okay? This one, use paper and a pencil to solve the problem and complete the what's my rule table. So I have x and y, so I have 0, 0, then 1 and a half, then I have 2, we got to figure that out for 3 as well, then I have 4 and 2. So I can tell that 1 and 0.5, y is half of x, right? Same with this one, y is half of x. For 2 is half of 4, and 0.5 is half of 1. So I know that my rule, you could say they're dividing by 2. They're dividing the x in half, or I can say multiplying by a half. It's the same thing. Or I should say dividing by 2 or multiplying by a half is the same thing. So I'm going to say multiplying by a half. Okay? So if I multiply 2 by a half or divide it divide it by 2, I would get 1. Half of 2 is 1. Half of 3 is 1.5. Half of 4 is 2. And then now we already have the half. So we got to figure out, okay, I know that 14, half of 14 is 7. So that's how I came up with the numbers that were missing there. So describe the rule in words. I would say in words that we have our x, and then we multiply that by a half. So I'm going to multiply it by 0.5. I guess that would mean my rule down here, or my equation, be y equals x times 0.5. And I guess since it says words, I should have wrote x multiplied or times 0.5, or a half if you want to write that out. Then this one says write the numbers in the table as ordered pairs. So that means ordered pairs. This is important. It means 0, 0, because I have x, y. Ordered pairs, think of x, comma, y in your parentheses. Then I have next one is 1, comma, 0.5. Okay. The next one is 2, comma, 1. I'm getting these because I'm looking at my x and I'm looking at my y right here on my table. The next one would be 3, comma, 1.5. Then we have 4, comma, 2. Then we have 14, comma, 7. Okay, so now I need to graph these. So 0, 0 is an easy one. It's in the corner there. Now I have to pay attention to how my graph is going up with numbers. So across the bottom is always my x, and going up and down is my y-axis. So I go over x and then up y. So over to 1, since this goes 0 to 2, 1 is right in the middle. And then up 0.5, which is a half, is right between 0 and 1, going up. So we have it that way, okay? And then I have going over 2, up 1, okay? And then I have going over 3, up 1.5, going over to 4, up to 2, going over to 14, and then up to 7, which here's 6, here's 7. I'm gonna make sure I'm still on the 14 line. Okay, so then I would draw my line. All right, use your rule to find the number of quarts of milk for 15 pints. So if I have, this is pints of milk in the X column, or the X axis. So if I go 15 and go all the way up here, it looks like it would be somewhere around right here if we're looking at our graph. So let's try putting 15 in for our equation up here where we wrote on line C. So we wrote y equals x times a half. So if I have y equals 15, because I'm putting 15 in for x, times that by a half, that would mean that half of 15 would equal 7.5. So 7.5 for y would equal 7.5. So that would make sense. Okay, and I even put it perfectly on my graph because here's 15, go all the way up, and there's 7.5. Okay, so my answer would be 7.5. Okay, so write an equation that you could use to find the distance y that a train travels in X hours. So if I look at the graph that they give us, it looks like in 1 hour, our train is traveling, I know that this is going up by 20s. So 2, 40, 60, 80, 100, okay? So I kind of looked at the graph ahead of time and I realized it had to be increasing by 20. So I know that at 1 hour, my graph tells me that the train is traveling 60 miles per hour, okay? So my equation is going to be y equals 60 miles an hour. So for every hour that my train is traveling, it's going 60 miles. Okay, so 60 times x, for x is going to represent the amount of hours. Okay, so that would be my equation. So if I was to use my graph or the equation to calculate how far the train travels in 2.5 hours, I would go to 2.5, which is right between 2 and 3, go all the way up, and it looks like it is right about, it crosses 2.5 right here. So that would be about 100 and this would be 120, 140, 160. So right in between that 140, 160 would be 150 miles. Okay, so let's see if that works. So I'm going to put 150 in for y. So this is my equation. If I replace y with 150, I'm going to put 150 equals 60 and then 2.5 hours to make sure that works. So 2.5. Okay, so I know that 60 times 2.5 is going to equal, if you type that into your calculator, it is going to equal 150. Okay, so if I have 150 equals 150, then I know I'm correct that the train will travel 150 miles in 2.5 hours, because they wanted to know how far the train travels in 2.5 hours. So I have 150 miles. Explain how we found that answer. Well, I looked at my graph first at 2.5, and I went up to where that line was crossing. At about 2.5, it was crossing 150, because it's right between, if it's going up by 20s again, 120, 140, then 160 here. So right in the middle would have been 150. And then I plugged in 150 for my y just to double check in my equation. So I took this equation and I put in 150 equals 60 times 2.5, because x represents the hours, which they gave us 2.5 here. So I substituted 2.5 in for x and solved, and I checked on the graph as well. Okay, so for the very last one, says choose one of the graphs and describe a situation that can be represented by it. So I could choose graph D, okay? And I could say I took a frozen pizza out of the freezer and I warmed it up in the microwave, and then I let it sit out on my kitchen table and it got cold again, okay? Because I can see here in graph D that it starts below 0 and it increases. So this could be the time that I am microwaving. So I can write this here. It starts in the freezer, and then I could microwave it, and then I could leave it right here on the table, and then it could decrease as it got colder, is left out, we'll say. Okay, so really there's so many different things that you could come up with. Graph A, you could say that the field of the soccer field was the length of the grass. So the grass was cut, so the height is lower, and then the grass grew again, and then it got cut, same length, grew, got cut, grew, got cut, grew, got cut. Okay, assuming that they are mowing the grass on a consistent basis and cutting it the same length each time. So I hope this review helps you, and you study for the test coming up on Tuesday. And please let us know if you need any help with anything prior to the test, and we would be glad to help you. Thanks for watching.